All right, today we get to continue with some more trigonometric identities. So we're going to step up the level of difficulty a little bit in this video. And simplifying these, there isn't going to be like this one-size-fits-all approach that there was in the last worksheet that you did, where it was just always replace it with sines and cosines, and boom, do a cancellation, you're good to go. This is going to require a little bit more thinking, if you will, a little more problem solving. And there isn't, again, like this one size step by step you're going to do for all of them. So you're also going to need to rely on some of your algebra skills. And there might be a problem or two that you just simply can't get on this, and that's okay. I just want you to make sure on the assignment that you are showing your work, show me that you tried some different things. But if you can, I would like you to try to solve all of them. But if you're just really stuck, you've spent 20 minutes on this question, by all means, show me some work, and that's okay. All right. So I'm going to go through and just basically outline some different strategies for simplifying these, and we're also going to be verifying trig identities as well. So let's go ahead and just, again, let's just go through some example problems. There isn't like some steps I can outline for you, so just sort of take note of these. If you want to write them down, that'd be great. Or you can at least, when you're looking at the homework, look for a similar problem. I'm going to try to do one that's similar to all of your homework problems. So our first one here, A. We've got a plus sign up here, which is going to make things a little bit more challenging. So generally, if you have a plus or minus on a fraction, the first thing we actually want to do is kind of separate this. So in doing that, what we're going to do is we're going to write this as tan theta over tan theta plus cotan theta. And now this cotangent also has to have the same denominator of tan theta. Because if you remember, when you add fractions, you add the numerators and you keep the denominator the same. So if we were to combine these two fractions, it would be tan theta plus cotan theta over just the tan theta because they have the same denominator. So we're just kind of undoing that. And in doing so, it works out kind of nicely because you can then see tan theta over tan theta. Well, that's just 1, right? And now cotan over tan, maybe that's not quite as obvious what you need to do there. So let's go ahead and let's change those to sines and cosines. So cotan, hopefully you're getting a good idea of what these are. Cotan is cosine over sine, and tan is sine over cosine. So hopefully you don't have to look all of these up every time. All right, now this is good because it looks like we might get some, like at least some cancellations or multiplications or something like that. So then from here, let's go ahead and flip and multiply. So this is going to be 1 plus, and this is going to be cosine theta over sine theta times, we flip it, it becomes cosine theta over sine theta. Now these don't cancel, but that's okay for now. So we get 1 plus cosine times a cosine is a cosine squared, and a sine times a sine is a sine squared. All right, now we have a cosine squared over a sine squared. So if you just kind of ignore the squareds and think about, well, what's cosine over sine? Well, cosine over sine is cotangent, so it would be 1 plus cotangent squared theta. Now, notice in the directions it doesn't say simplify to a single trig function or a constant. It just says simplify. So there isn't necessarily a real answer for this. However, you should be able to just simplify it quite a bit until you don't have a lot left over. You shouldn't have any fractions when you simplify. In most cases, there shouldn't be a fraction. We're done with it. So that's a pretty good answer, 1 plus cotangent squared. There's not really any way we're going to get rid of that plus sign. So this is a pretty good final answer. Again, we're just simplifying it, showing that we know how to use these trig identities. Okay, let's go ahead and look at the next one. This one, I think, is actually one of the more challenging ones that you probably wouldn't have any idea how to approach this one. You might start by just replacing the top with 1 minus sine squared theta, or 1 minus sine theta. And then you might try to cancel, but you're not allowed to do that. You can't just go canceling things. Maybe you try to split it up or whatever. This one is, like I said, it's pretty challenging. There's one like this. I think it's number 2 on your homework as well. What you actually want to do in this one, I'm not sure if you've ever seen this before. You might have, but we're going to, it's called the the conjugate. We're going to multiply by the conjugate of the denominator. The conjugate. You might have seen like multiply by the complex conjugate when you have like when you're dealing with i's and denominators maybe. But the conjugate is just basically the denominator except with an opposite sign. So we're going to multiply this by 1 plus sine of theta. And we've got to do that for the top as well, because what we're actually doing is just multiplying this whole thing by 1, because anything over itself is 1. So it's called the conjugate. It's just the same thing except it's an opposite symbol of what's there. All right, and I'll show you why we're going to do that. To get rid of that in the bottom, well, the top I'm just going to leave as cosine squared. I'm just going to put parentheses 1 plus sine for right now. We'll deal with that later. But on the bottom, we actually need to FOIL this bottom, because we've got this thing times this thing. So when we FOIL, we do 1 times 1 is 1. Now we do our outer is 1 times positive sign. That's going to be a plus sine of theta. When we do our inner, it's going to be minus sine of theta times 1, so minus sine theta. And our last is going to be minus sine theta times sine theta, so minus sine squared theta. That's what we end up with. And then the nice thing there is the middle terms cancel. Boom, boom. And so we end up with 1 minus sine squared theta. All right, now it might not seem like that's helpful at this point, but trust me, it is. Some of these you just got to play around with and work until you can cancel. All right, so that's what we're left with. Now, the reason why that's a good thing is because we can replace 1 minus sine squared theta, but we couldn't have replaced this just 1 minus sine of theta. We didn't have a trig identity for that one. But we do know 1 minus sine squared theta is cosine squared theta. So on the top, I got cosine squared theta times 1 plus sine of theta. And on the bottom, I'm going to go ahead and replace that with cosine squared theta. And you can see there we get a good cancellation. Boom, boom, those cancel. And so we're left with 1 plus sine of theta. That's our answer. Again, it's not a single trig function, but it's pretty darn close. So we're good with that. And again, you'll do this on number 2 of your assignment. Believe it's this one right here. So on number 2 there, what you're going to do is multiply by 1 minus cosine of theta over 1 minus cosine of theta. Do a very similar strategy. Cancellations and everything will work the same way. So again, we're going to be doing some that look very similar to this stuff. All right, let's go ahead and do our next example. Secant squared minus 1 over secant squared. Okay, so let's take a look at our trig identities, see if there's something that would be helpful here. Secant squared minus 1 over secant squared. We do have a secant squared minus 1 equaling tangent squared. So let's go ahead and try that. So this would then become tangent squared theta over secant squared theta. Okay, that's pretty good. Now, we obviously can't leave it there. But at this point, we got rid of that minus 1, so that should make things easier. And let's go ahead and turn these to sines and cosines. So tangent is the same thing as sine over cosine. So tangent squared could also be sine squared over cosine squared. And secant squared, if you remember, is 1 over cosine. So this will be 1 over cosine squared. All right, and then you should start to be thinking ahead when you flip and multiply here that you're going to get some cancellations, so that will be good. So this becomes, we keep the top, and then we multiply by the reciprocal, so the bottom flipped. And good news, those cosine squares are opposite, so boom, they cancel. And then we're just left with sine squared over 1, or just sine squared. All right. So you really just got to mess around with these. It just takes experience to figure these out. Let's go ahead and try some more. This one we can make some substitutions. This one, it'd probably be fine to just go ahead and replace everything with sines and cosines on this one. Let's go ahead and do that. So this would be tangent is sine over cosine. Cosecant is 1 over sine. And then we've got cosine. So let's start that as cosine over 1, just to make things look a little easier. All right. Now you'll see we get some good cancellations because these are diagonal from each other, so they cancel. And this cosine are also diagonal from each other. They cancel. So all we're left with is a nice happy 1. All right, so that one ended up being pretty easy. Okay, now the next section, this is going to be called verifying identities. Now what we want to do on this one is you can just basically think of this as a proof. So if you remember back in geometry where you had to prove something, I'm not going to require you to like state the reason why you did things, but basically we're just trying to prove that this left side equals the right side. And it says here you can work on each side separately, but you can't move things to the other side. So you just got to work on one side and the other side separately. Again, you can't move things. Make sure you don't move things from one side to the other. Okay. So we're just going to try to make one side look like the other one. I'm going to start with the left side because there's a lot of work to do there, and there's nothing I can do with a 1. So okay, I suppose you could actually replace that with 1 minus sine squared or 1 minus cosine squared. But for now, let's look at the complicated side. Let's go ahead and just try our strategy of replacing all these with sines and cosines. So cotangent is our cosine over sine. And secant is 1 over cosine. So this one's going to actually work out very nicely for us. Same thing as we had happen in the last question. This sine and this sine cancel because this is really sine over 1. And this cosine and this sine cosine cancel. So we just get 1 equals 1. You do need to show what you did in your simplification there, or your substitutions there, to show that it does equal 1. Because I've already told you that it equals 1, you got to prove that it equals 1. All right. Next one. 1 minus 2 sine squared equals 2 cosine squared minus 1. Looks a little bit confusing. Again, you can't move things around, so you can't like add the 1 over. You just got to work with each side separately. So what I'm going to do is I would just like to start with the left side. So let's replace the only thing we really can, which is this, sine squared. And if I'm thinking ahead about what sine squared replaces with, remember that's 1 minus cosine squared. And that'd probably be a good thing because this one has a cosine squared. And if I'm trying to get them equal to each other, then replacing this with something the other side has is probably a good strategy. So I'm going to replace that with 1 minus cosine squared. I'm just going to keep this one the same. And see what I can do to simplify this one over here. So this 2 multiplies in. This becomes 1 minus 2. And then this 2 times this becomes a plus 2 cosine squared theta. So all I did was distribute that negative 2 in there. And then let's see what happens. This is still 2 cosine squared theta minus 1. I need to get the left side to look like that right side. So if I combine these two, 1 minus 2 is actually negative 1 plus 2 cosine squared theta. And I'm almost there. All I need to do is just rearrange this. So since they're adding these, we can just switch the order. And this just becomes 2 cosine squared theta minus 1 equals 2 cosine squared theta minus 1. So I've proved it. Whoa, what happened there? All right. Let's go ahead and do a couple more. Almost done. All right. So the next part, they actually want you to do a little warm up with factoring because you're going to be needing to do some factoring in this next section. So it's just a little rejuvenation of your factoring skills. This is just 2 terms. Sorry, not sure that keeps happening. This one is 2 terms, a squared minus a squared b. So whenever you see 2 terms, think GCF, pull out a GCF. So in this one, we'd pull out an a squared, and we'd be left with 1 minus b. So that's all you're asked to do there. The reason why is we're going to do that with the next problem, is we're going to pull something out. Okay, and this one over here, when you have 3 terms, think about factoring as these 2 sets of equations, or 2 sets of parentheses, and this one is going to be an x and an x because it's x squared. And then we have to think about what multiplies to give you 1 and adds to give you negative 2. Okay, so that's going to be minus 1 and minus 1, right? Because your first gives you x squared, middle outer gives you minus x and last gives you plus 1. So just a little refresh on how to factor. And we're doing that again because we're going to need to factor for this next section. All right, so this first one, the reason why, again, we did this GCF factoring is because this actually has a GCF we could pull out. Just instead of a's, it has cosecant squares. Both of these terms have a cosecant squared. So we're actually going to pull that out. And then, well, cosecant squared times 1 equals cosecant squared. And then with this other one we have left over is a minus cosine squared. So it's kind of like undistributing, if you will. Because if we were to distribute this back in, we'd end up with our original part here. It's like undistributing. Okay, and the reason that we do that, obviously, is so we could simplify it in some way. And if I keep this cosecant squared as is for right now, this 1 minus cosine squared, remember that's the same thing as sine squared. So this is good because we got rid of that plus sign now. That should make things easier. And then now let's do our strategy of just replacing with sines and cosines. So cosecant is the same thing as 1 over sine, so this is actually the same thing as 1 over sine squared. So now we've got 1 over sine squared times sine squared. Good news there, sine squareds cancel. So we're left with just 1 equals 1. So we have proved that identity. It's called verifying the identity. Okay. This next one has a note. It says that you can get your answer in different ways for this. I'm not going to be picky on how you leave your final answer, but we're just basically going to try to simplify this. And since this is 2 terms in parentheses, you want to think here as FOIL. Okay. So when we do that, sine times sine, that's sine squared theta. Outer, sine times cosine, we're just going to say plus sine theta cosine theta. In the inside here, this is minus cosine theta sine theta. And our last one, minus and a plus, would be a minus cosine squared theta. Now these middle terms are actually, even though they look a little bit different, they're the same. These are just reordered here. You're allowed to switch those around because it's multiplication. So this actually cancels with this. And we're just left with sine squared theta minus cosine squared theta. All right, now you might be thinking that looks like something we could use, right? It's not 100% correct. Where is it here? Because this is actually cosine squared plus sine squared, or sine squared plus cosine squared equals 1. And ours, unfortunately, is a minus. So there's a way we can actually get around this. And that is, well, the way that we can get around this is to pull out a negative. I would say for now, this is probably okay. Let's go ahead and just replace this cosine squared with a 1 minus sine squared. Yeah, this will probably be the easiest way to explain it. All right. So since I know cosine squared is 1 minus sine squared, I would then distribute this, and I would get sine squared theta minus 1, and this becomes plus sine squared theta. So that actually doesn't really help us a whole lot. I guess you could then combine these two. Sine squared and a sine squared becomes 2 sine squared theta minus 1. I guess you could say that's a little bit more simple. This one does say leave it in terms of sine squared. So, all right, we simplified it. Again, when you simplify these, there isn't necessarily one correct answer. You maybe could have stopped here, but I guess this is probably the best answer. Again, this does not equal 1 because it's sine squared plus cosine squared, and then we have a minus, so that does not equal 1. All right, I realize you're probably getting a little bit confused at this point. Hang with me. Let's do 2 more. And again, I don't expect you to be an expert at this. This will be one of the harder things we do. I just want you to basically try and struggle and try to get these. All right, so this one, to simplify this, we're going to need to get rid of that squared. Now, you can't just square each individual one. You need to write this as tan theta plus 1 times tan theta plus 1. because the addition sign in there doesn't allow you to just square them individually. You got to rewrite them like that and then FOIL it. So then you get a tan times a tan is a tan squared. Our outer would be plus tan theta. Our inner is also a plus tan theta. And our last is a plus 1. All right, so let's see what we can do from here. What are some possible things we could do? All right, well, let's combine the middle two things first. Those don't cancel, unfortunately. They're just 2 tan theta plus 1. And let's think about what we could replace tan squared theta with. Maybe there's just something with a 1 where we could get this positive 1 to cancel. Let's look here. So for tan squared theta, we do have some options here with a 1. And let's go ahead and just replace it with secant squared theta minus 1. And I'll show you why here. So if we replace that with secant squared theta minus 1, so we replaced it with, plus 2 tan theta plus 1. The reason why this is kind of good is because we got this minus 1 and a plus 1, and those will cancel. So now we've got it to secant squared theta plus 2 tan theta. All right, it's not so bad. Let's see what we can do from here. So maybe we can replace these with some sines and cosines. Secant squared is the same thing as 1 over cosine squared. All right. Plus, and then 2 tangent, remember, a sine over cosine. All right. Maybe we could try to combine these with the same denominator, I guess. You might even decide you want to stop here. That actually might be the best idea. But I'm going to just keep going and see what we can do. All right, I'm going to try to write these over the same denominator. So in order to do that, to combine these, I would need to multiply this by cosine over cosine. And then we get 1 over cosine squared theta plus 2 sine theta cosine theta over cosine squared. And then we add those numerators, 1 plus 2 sine theta cosine theta. Might actually just made it more complicated. I don't know. Cosine squared theta. Yeah, I probably just ended up making it more complicated. So let's just leave it as this one. I think that's probably the best you can do. I don't know. Maybe you could try that on your own and get it more simplified. All right, let's try the next one. This one's actually going to be a factoring. If you think of this sine squared instead of like an x, if you think of it just as x squared minus 2x plus 1, it's a little easier to think about factoring this, because then you would do your 2 sets of parentheses. And instead of having an x and an x, you're going to have a sine theta and a sine theta. And then this would generally be a minus 1 and a minus 1, right? And that will still be the case here, right? Because if you were to FOIL this through, you would get your minus sine theta and minus sine theta, and then you got your plus 1 at the end. All right, so that works. Now from here, I don't know that it actually makes sense to do much else from here. I'm trying to think what else would make sense. I think that's about it. So not really much you can do to simplify this. It's probably actually more complicated. So yeah, I think that's about all you can do. All right, so we'll leave that one as there. On your homework assignment here, you can see you've got a few with the fractions and replacing. Those should be very similar to the first 4 that we did up here. You've then got some where you have to try to verify. To do this, remember, you try to make one side equal the others. So in most cases, you're going to try to make the left side equal the right side. This first one, you should just be replacing. So number 5, you should just be replacing these. This next one, you are going to need to FOIL that and see if you can get it to look like this. I think that should be doable. This one, you're going to distribute. And then I would probably replace that cotangent squared with cosine over sine squared. That should work out. This one, actually, it's multiplication. They already did the multiplication for you. like the conjugate there. So you're just going to multiply this straight across and see if you can end up to look like this. So I think we'll skip those other ones for right now. So try to do those 8 problems. Do your best on them. Again, if you get really stuck, don't worry. You should be able to get something decently simplified. I guess you don't actually have any like these last 2 that I just did. I shouldn't have to worry about those. So, all right, good luck, guys.